Okay, g'day students. Welcome to the lesson. We're in lesson 9 today. So we're looking at increasing a value annuity. So remember, annuity is this stream of income. And we're looking at perpetuities a little bit as well. Okay, so let's move on. An interesting form of investment is that of an annuity. So this is where you're starting off a lump sum and you get these periodic payments given to you. The problem though is that inflation will actually reduce the value or the buying power of that money in the future, so that this money will lose value over time. So let's have a look at this example. We've got Zach here. He's got an annuity for $250,000. So that is his principal. What are you starting off with? Well done, Zach. I don't know where you got your hold of $250,000 being in year 12. Maybe it's down the track. And we're going to use this relationship now to calculate the value after 6 months. So what do we say? It's the growth rate. So that's our R. So it's 1 plus the interest rate. What's our interest rate? It's 4% per annum. So 0.04 per annum. Now we're told every 6 months here. There's 2 lots of 6 months for every 12 months. So that's our growth rate. Now let's multiply it by our amount, which is this $250,000. And we also need to then take away that $4,500. And that should give us $250,000, 500. So this looks all right. The value of the annuity is actually increasing, isn't it? It's after 6 months, he's got $500 extra. That seems to be pretty good. Let's continue this. So for the second lot of 6 months in the year, 0.04 over 2. Now we're using this one now because A1, and so that fits our recursion formula. So multiply by 250,500 and take away that periodic payment of 4,500. That's going to give us $251,000.10. So the value after 1 year, or those 2 compounding periods, is going to be $251,000.10. Now let's consider the cost of inflation. So we said that inflation was 3%. So what we will do is just go, well, our growth rate then has got to be 1 plus that 3%. So 1 plus 0.03. And let's then calculate the how much that inflated value of the, what do we call it? The future value of the principal. So it's just going to be 1.03 times $250,000. So this is what it would be worth down the track, and that should give us $257,000. So what can you say? Well, this one's bigger, isn't it? So the annuity has not kept. No, the annuity is smaller. Or that investment there is actually smaller than the inflated value down the track. Okay, however, when we take out an investment in an annuity, sometimes we just start off with a smaller sum of money. So we use this for a savings tool, for example, going on holidays. Now, superannuation is a good example of this annuity investment. It starts with a small lump sum, but your superannuation will not, of course, because when you start on day one, you're starting with $0, and then you will be putting into your superannuation each week. Anyway, we've got Cooper today. He's inherited $2,000 and he's decided to invest $50 a month with an interest rate of 2.5%. Maybe he needs a new haircut. Calculate the value of the investment after 3 months. So what do we know? We know the initial amount, don't we? So that's our principal. So it's $2,000. Oh, do we know a growth rate? Well, kind of. We've got it 2.5% per annum, but we notice that it's going to have to be over 3 months. So that's R sorted out. That's that one sorted out. And this D, this is what our D is going to stand for. So that's a deposit we put in each time we compound. So let's have a look at what this looks like. So AO is that. So we know what AO is. Let's use our formula now to calculate what it would look like after 3 months. No, after the first month. So month 1, what's our growth rate? Well, it's 1 plus. Now our annual interest rate is 2.5%, isn't it? That's meant to be a 2. But it's 3 months. So no, we are calculating this monthly. Look at what I'm doing. So it's got to be over 12, hasn't it? But we've got to carry this out 3 times because we're looking at 3 months. Now we're going to multiply that by the initial investment. So that's here principal, $2,000. And Cooper's putting in $50 each time. This annuity is calculated, and the interest is calculated. So that's going to equal $2,054.17. Now these sorts of things were quite popular back in the day as well. Not so much anymore except for superannuation. Now let's have a look at the second month. So it's 1 plus. Well, we've still got our 0.25 over 12 times. Now what do we do here? So this is this one. We have to use the previous one here. So it's just 2,054.17, and then we have to add on that D for the deposit there, and that's going to be $2,108.40 at the end of the second month. He's put in an extra $100. He's earned a huge $8.40. That's a hamburger at Macca's, isn't it? Extra interest. Nearly. Let's do our third month calculation, and we'll call that a day on this one. So it's 1 plus 0.025 over 12. Now we use that 2,108.40, and then we add on the D for deposit, and that should get us 2,162.84. So the value of the investment after 3 months is $2,162.84. Okay, folks, I reckon you can now use that recurrence relationship in your mastery exercises on 6.5 for me, please. Have a good day.